Today we are doing the first set of notes from the quadratics chapter, and we're going to be talking about graphs of quadratics. So the first question says, what is a quadratic function? So anything raised to the second power is considered a quadratic function. Sometimes there's more terms, but anything with an x squared in it is quadratic. What does the graph look like? The graph is a parabola. So that is the name of the shape. And the shape is that it looks like a U, or it looks like an upside down U. Some properties of parabolas. So the axis of symmetry is a vertical line that cuts the graph in half. Your axis of symmetry is always going to be x equals a number. The vertex is either the highest or the lowest point of the graph. Oops, let me reset. It depends which way the graph is facing. So if the graph is facing up, your vertex is at the bottom, and if the graph is going down, your vertex is at the top. So I think for max and min, we're just going to draw pictures and we'll kind of label. So when your graph looks like this, your vertex is going to be located right here, and that is considered a max. If your graph is an upside down U, or sorry, regular U, the vertex is now located right here, and that is a min. So it all depends which way the graph is facing to determine if you have a maximum or a minimum value. So here we're going to go over some terminology. I'm sorry that the pictures are unclear, but on your paper, hopefully you can see the numbers a little bit better. So your axis of symmetry, again, you would have to draw a vertical line that cuts your graph in half, so that's going to be happening right here. So that is going through x equals 2. Your vertex is going to be this point right here, which is a 2, -1. So the vertex is always a coordinate pair. The question says, is your vertex a maximum or minimum? So this is a min because my vertex is the lowest point of the picture. Your x-intercepts are where we are crossing the x-axis, so it's going to be happening twice. It's happening right here and right here. So my x-intercepts are happening at 1. Oh, let me change that color so you can see it better. 1 and 3. You could also write it as 1, 0, and 3, 0. You could write it as coordinate pairs. The y-intercept is where it's crossing the y-axis, and that is happening right here. So your y-intercept is happening at 3. And remember, domain is left to right, x values, so there are arrows on the end of this parabola. It goes forever, so my domain is -infinity to +infinity. That's always going to be the domain for quadratics. The only thing that will change is your range, and that all depends on what the picture is. So remember, your range is your y value, so let me take all this stuff off. The range is your lowest point, which is -1, and it's included because it's a closed dot, and then this graph goes to infinity forever. I would like you to complete that next one as a practice. So go ahead and pause the video and try that one. We'll go over those answers in class. The next thing that we're going to talk about is average rate of change. Again, we spent some time talking about this in the second chapter already, so hopefully this is a little bit of a review. So remember, I will always give you the x values that we need to use. I typically set up a little table for myself, and because I gave you the two x values, we're going to put those on the x side. You're going to use the graph to find the matching y values. So when x is -1, my matching y value is all the way up here. When x is 0, my matching y value is 3. So again, this one goes 0 goes with 3. and negative 1 goes with 8. And then we find the change in y over change in x. So my y values are going down by 5. My x values are going up by 1. So my slope is negative 5 over 1, which would just reduce to be negative 5. You could also approach this with the picture. You could just go down 5 into the right one, and you could just look at it that way. I don't have room on my screen for the second one, so I'm going to write it in this spot right here. Please make sure you put it in the appropriate spot on your paper. So they're now saying 2 and 5. So notice they wrote it a little bit differently. They set it up as an interval, so they're just saying what's the average change between 2 and 5. So this is just a different way of presenting the information. It means the same thing. I'm giving you the x values. I want you to find the matching y values. So when x is 2, my matching y value I'm looking for is negative 1. And when x is 5, the matching y value is positive 8. So again, my y's are going up by 9. My x's are going up by 3. So my average rate of change is a positive 3. You could have also counted up 9, right 3, and still got a slope of 3. So whichever way you prefer is fine. Again, you're going to try the second one as practice, so let's label that this is your practice problem. So try that one, and we'll go over that in class. So last thing that we're going to talk about are just some quick key concepts that are important for quadratics. So it says the following table represents the quadratic function f of x, and it says the axis of symmetry of the function is at x equals 3. So we know that the axis of symmetry goes through the vertex of the picture. So I'm going to go here and I'm going to label that my vertex is at 3, 6. And it says complete the table. So one of the things that we know is that around the axis of symmetry, all my y values repeat. So these two coordinates should be the same. These two spots will be the same, and those two spots will be the same. So around the 6, my matching y values are 5. After the 5s, we go with the 2, and then I go with negative 3. Okay, so again, those matched, the 2s match, the 5 match. There's my vertex. Now they want us to plot the points, so we're going to go ahead and draw this graph. I want to put my y-axis all the way over here because all my x values are positive, so I need to have room to go to the right. And my y-axis I'm going to put about there, so that way I have mostly positive y values. I want to make sure I can plot my whole picture. So for the first coordinate, it says 0, negative 3. That's down here. Then I have a 1, positive 2. Then I have a 2, 5. Then I have a 3, 6. And then after this point, you're going to notice they start coming back down. So it goes to 4, 5, to 5, 2, and to 6, negative 3. And notice here is my parabola, and the axis of symmetry, like we said, is going through 3. So if you wanted to plot the points first, you could have plotted the points that were given to you and then filled in the table after. Here it says a quadratic equation has zeros, which means x-intercepts of 5 and negative 2, and it says what's the axis of symmetry. So if I were like to draw a rough sketch, I'm just going to go ahead and draw an xy axis on here. It's telling me that it's crossing the x-axis at positive 5, and it's crossing the x-axis at a negative 2. So if I wanted to find the axis of symmetry, I need to locate the vertex. And the vertex is going to happen dead smack in the middle between these two things. So we can kind of work our way in until we find the middle. So I'm going 1 unit on each direction. Then I go 2 units in that direction. Then I'm going to go 3 units. And my midway point is going to be dead smack in the middle between those two x values. So my axis of symmetry is going to be happening at 2.5 for this problem, because that's halfway between 5 and negative 2. And the last thing that we're going to talk about today is the number of zeros a parabola can have. Again, it's important that you highlight that zeros mean x-intercepts. It also means solutions, and you're going to see different terminologies throughout the lessons. So let's go ahead and draw your XY axes on all 3 of your pictures. And if a graph were to have 2 zeros, it would look like that. So again, your zeros is where you cross the x-axis. It could also be going upside down. The second one says 1, 0, and 1, 0 happens when the graph only intersects the x-axis one time. So the only way that would happen is if my vertex was on the x-axis. So here, that's only crossing one time. So that's an example of one solution. Again, it could also go up. So if it has no zeros, it can't cross the x-axis at all. So it could go somewhere down here, or it could be somewhere up here. But notice neither one of those graphs that I just drew are crossing the x-axis. So that's an example of something that is no solution. So that's all for today. You have 2 more practice problems to try.